After this lesson, students will be able to multiply and divide rational numbers and simplify exponential expressions. Try these problems on your own, so pause the movie and resume when you're ready. Number 1. Negative 45 minus 23. These are the same sign, since they're both negative. So according to our wrap, same sign, add, and keep. 45 plus 23 gives us 68, and I keep my negative sign. Number 2. The minus and the minus are right next to each other. So they're buddies, and they get along, so they join forces and make a plus sign. Negative 67 plus 33. Now we have different signs, so we subtract. 67 minus 33 gives us 34, and since our larger number is negative, we take the sign of the higher number and get negative 34. Number 3, we have positive 50 and negative 84. These are different signs, so I subtract 84 minus 50, and I take the sign of my higher number, negative 34. Now number 4, the plus sign and the minus sign are right next to each other. They are enemies, and they get in a battle where the plus sign always loses. So we have 71 minus 90. Now we have different signs, so they get subtracted. 90 minus 71 gives us 19. Take the sign of the higher number, which is negative. Number 5, negative 18 plus 29. I have a negative number and a positive number. Different signs, so I subtract, and I take the sign of the higher number, which this time is positive. Number 6, the absolute value of 17. Well, absolute value is the distance of a number from 0 on the number line. Since 17 is 17 spaces away from 0, our answer is 17. For number 7, negative 43 is 43 spaces away from 0 on the number line. So the absolute value of negative 43 is 43. And number 8, negative absolute value of 32. We take the absolute value of 32 first, which is 32, and then we take the opposite. So our answer is negative 32. Today we're going to talk about multiplying and dividing integers and some other rational numbers. The wrap can only be used for adding and subtracting. So as a reminder, I'll play the wrap for you one more time. Same sign, add and keep, different sign, subtract. Take the sign of the higher number, then it'll be exact. Raise the roof. Now for multiplying and dividing, we cannot use this wrap. Instead, I have an acronym I like to use, SPUN. S stands for same, P stands for positive, U stands for unlike, and N stands for negative. What this means is that when we have two numbers with the same sign, so either both are positive or both are negative, and we're multiplying and dividing them, we get a positive answer. If they are unlike signs, meaning one is positive and one is negative, then we're going to get a negative answer. So here are a few examples. Number 1, negative 5 times negative 3. At first, I can completely ignore the signs and say that 5 times 3 is 15. Now, I check to see do they have the same sign or unlike signs. Since they're both negative, they have the same sign. So same gives us a positive answer. positive 15. Number 2, I start by doing 6 times 3, which is 18. 6 is positive and 3 is negative. They are unlike signs, so I'm going to get a negative answer. Number 3, I have negative 8 times positive 4. 8 times 4 is 32. They are unlike signs, so the answer is negative. Number 4, 10 times 5 is 50. One's positive and one's negative, so my answer is negative 50. Number 5, negative 20 divided by 5. 20 divided by 5 is 4. They are unlike signs, so I get negative 4. Number 6, 42 divided by negative 7. Well, 42 divided by 7 is 6, and they're unlike signs, so I get a negative answer. Number 7, negative 21 divided by negative 3. 21 divided by 3 is 7. They're both negative. Same sign gives me a positive answer. Number 8, negative 3 times 2 times negative 4. According to order of operations, once I get to just multiplication and division, I have to go from left to right. Now we could use the commutative property of multiplication if we'd like, but I'm going to start from the left and work my way over. So negative 3 times 2, those are different signs, so I get negative 6, times negative 4. Now they have the same sign, so I end up with a positive answer, positive 24. Number 9, 2 times 2 times negative 4. Starting from the left, 2 times 2 is 4, and 4 times negative 4, unlike signs, gives me negative 16. You try these on your own, pause the movie, and resume when you're ready. Number 1, you should get negative 48. Number 2, you get negative 6. Number 3, positive 88. Number 4, negative 54. Number 5, positive 4. Number 6, 35. Number 7, negative 4. Number 8, positive 8. Number 9, I work my way from left to right. I get 80. And number 10 gives us an answer of negative 10. So now let's practice multiplying with fractions and decimals. Spun still applies. So for negative 1, or for number 1, we have negative 4.9 times negative 8. They're both negative, so the same sign is going to give me a positive answer. Now I just have to do 4.9 times 8. When multiplying with decimals, I do not need to line up the decimal point. That's only with adding and subtracting. So I line my 8 up to the right. I can ignore the decimal point for the time being and do 49 times 8. 9 times 8 is 72. 8 times 4 is 32, plus 7 gives me 392. Now I ask myself, how many total digits came after the decimal point in my question? Well, only the 9 comes after a decimal point, so 1. So in the answer, I should also have 1 digit that comes after the decimal point. So I get 39.2. Number 2, we're multiplying fractions. One is negative and one is positive. So my answer will be negative. Now with multiplying fractions, we have a couple different strategies. You can either multiply straight across, so our numerators, negative 2 times 3 is negative 6, and then our denominators, 3 times 4, which is 12, and then reduce. Another option would be to cross-reduce right away. So we look diagonally or vertically, and see if we can pull out any factors and divide them both by the same factor. So for example, I can divide -2 and 4 both by 2. So I end up with -1 and 2. The 3 and the 3 can each be divided by 3, which leaves me with 1 and 1. So rewritten neatly, I'd have -1 over 1 times 1/2. And then I can multiply across to get -1/2, which is the same answer we got with our other strategy. Now for number 3, I have 5 times -2/3. I can treat 5 as a fraction 5 over 1, and multiply that by -2/3. Multiplying straight across gives me -10/3, which is an improper fraction. So then I change it to a mixed number, -3 1/3. Now we're going to practice evaluating. If you recall, evaluate is another word for simplify. In this case, I'm going to be substituting numbers in for the variables and simplifying. So I have -2 times x, which is -20, times y, which is -3. I can start to solve from left to right. -2 times -20, which is +40, and 40 times -3, which gives me -120. You try the next 3 questions, so pause the screen and resume when you're ready. Part A. I have negative, and then in parentheses, c times d, which is -8 times -7. According to PEMDAS, I'm going to start within my parentheses, so -8 times -7 gives me +56, and then I'm taking the opposite of that, so my answer is -56. Part B. -2 times -3 times -8 times -7 in parentheses. I begin within my parentheses, which gives me 56. I recopy everything else. And now I can go from left to right. 6 times 56, which equals 336. And part C, we have -8 times the opposite of d. Since d is -7, the opposite of a negative would be positive. So -8 times +7 is -56. Try these 4 questions on your own. Pause the screen and resume when you're ready. Number 1, I know is going to give me a negative answer, since they are unlike signs. I can cross-reduce here, and I can even reduce the 2/8. So I'm going to begin actually by writing -4/5 times my 2/8 reduced, which is 1/4. And now I'm going to cross-reduce. The -4 becomes -1, and the 4 becomes 1. Now I have -1/5 times 1 over 1, or -1/5. Number 2. 6 is like 6 over 1 times -3 over 8. I can cross-reduce. This leaves me with 3 and 4. Multiplying across gives me -9/4, which equals -2 1/4 when written as a mixed number. Number 3. A negative times a negative gives me a positive. So now I just have to do 7.4 times 3.2. I ignore the decimals for the time being. 4 times 2 is 8, 7 times 2 is 14. Cross off my 2 and put a 0 as a placeholder. 4 times 3 is 12, 7 times 3 is 21, plus 1 is 22. Add these up. And now ask myself how many total digits come after the decimal points in the question. Since there are 2 in the question total, then I have 2 in my answer total behind the decimal point. So my final answer is 23.68. Number 4, I have a positive times a negative, so my answer will be negative. And I do 3.71 times 5.8. I do not need to line up the decimal points when I multiply, and I'm going to ignore them for the time being while I go through the multiplication process. 1 times 8 is 8, 7 times 8 is 56. This gives me 24 plus 5, which is 29. Cross off the 8 and put a placeholder of 0. 5 times 1 is 5, 7 times 5 is 35. And then the 15 plus 3 is 18. Add it up. And then there are 3 total digits that come after decimal points in the question. So I count 1, 2, 3 from the right and put my decimal point. This is a negative answer, negative 21.518. Now we're going to practice simplifying exponential expressions. These are actually trickier than they look. Number 1, negative 3 to the 4th power, without parentheses. We need to follow order of operations. Technically, the only thing being raised to the 4th power here is the 3, not the negative. If you'd like, you could think of this as being negative 1 times 3 to the 4th. We start by doing 3 to the 4th, which is 81, and then taking the opposite of that, which is negative 81. Number 2, I have negative 3 in parentheses raised to the 4th power. This means that I'm taking the quantity of negative 3 and multiplying it by itself 4 times. Negative 3 times negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 gives me positive 9. Positive 9. And so I get an answer of positive 81. Notice what a difference the parentheses makes between your answers in number 1 and in number 2. Now, it's not true that every time you have parentheses you're going to get a positive answer, because when we look at number 3, we're taking the quantity of negative 3 and raising it to the 3rd power, which means we're multiplying negative 3 times negative 3 times negative 3. This time, I get negative 3 times negative 3 is positive 9, but when I multiply that by a negative, I end up with negative 27. So even though the negative 3 is in parentheses and being raised to the power, it is possible to get a negative answer if your exponent is odd. Now number 4, we have negative 0.3 in parentheses raised to the 2nd power. So I'm going to be doing negative 0.3 times negative 0.3, which I know is going to give me a positive answer. Now I can just do 0.3 times 0.3. 3 times 3 is 9. I have 2 digits that come after my decimal points, so 2 in my answer. 0.09. Pause the screen and try the 4 questions on your own and resume when you're ready. Number 1. Negative 2 in parentheses raised to the 5th power. Because my exponent is odd, I know that I'm going to end up with a negative answer despite the fact that it's in parentheses. So I have negative 2 times negative 2 times negative 2 times negative 2 times negative 2. This makes 4, and this makes 4, and then I also have my negative 2. 4 times 4 is 16, and 16 times negative 2 is negative 32, our final answer. Number 2, I have a negative number in parentheses raised to an even exponent. So this one is going to be positive. Negative 2 times negative 2 times negative 2 times negative 2 gives me positive 4 times positive 4, or positive 16. Number 3 is not in parentheses, so I think of this as negative 1 times 4 to the third power. 4 to the third power is 64, multiplied by negative 1 gives me negative 64. Number 4, I'll have negative 3/4 times negative 3/4, which is going to give me a positive answer. 3/4 times 3/4 equals 9/16. So I get positive 9/16. Simplify the following expressions. Try these questions on your own and see how you do. So pause the screen and resume when you're ready. Number 1. When following order of operations, I'll be doing the exponents first in this case. So 2 to the 5th, which gives me 32. 3 to the 3rd, which gives me 27. Now here I have a choice, but I'm going to put my minus sign down and then do the 4 squared separately. So 4 squared is 16, which is positive. And then 1 to the 4th power. Be careful, this is not 4. It is 1 times 1 times 1 times 1, which is 1. Now I go from left to right. 32 plus 27, which is 59. I recopy everything else. 59 minus 16, which is 43 plus 1, and I get my answer of 44. Number 2. Order of operations says that I do what's in the parentheses first. So I get negative 3 in parentheses raised to the 3rd power, and that'll be multiplied by 5. Next, I do my exponents. Negative 3 in parentheses raised to the 3rd power gives me negative 27, which I can then multiply by 5. I'll get a negative answer, 135. So my final answer is negative 135. Number 3. When it's written as a fraction like this, we simplify the numerator, simplify the denominator, and then divide. So I start by doing negative 3 times 12, which is negative 36, divided by negative 72. A negative divided by a negative, since they're the same sign, gives me a positive answer, and I can reduce 36 over 72 by dividing both the numerator and the denominator by 36, and I get positive 1/2. Okay, evaluate negative x over negative 4 plus 2y divided by z for x equals negative 20, y equals 6, and z equals negative 1. Well, negative x is like saying the opposite of x. So the opposite of negative 20 would be positive 20 over negative 4 plus 2 times y, or 2 times 6, divided by z, which is negative 1. So, since there's nothing to do within my parentheses, and there are no exponents, I go and do my multiplication and division from left to right. 20 over negative 4 means 20 divided by negative 4, which is negative 5. And I recopy everything else. And now I do 2 times 6, which is 12, and I recopy everything else. And then I divide 12 divided by negative 1, which gives me negative 12. And now I have a plus and a minus right next to each other. They're enemies, they get in a battle, and the plus sign loses. So negative 5 minus 12, same sign, add and keep, gives me negative 17. Pause the screen to try this question on your own and resume when you're ready. We have negative x, which is 4, over y, which is negative 2, minus 4 times z, which is negative 4, squared. There's nothing to do within the parentheses, so I'm going to do my exponents. Negative 4 in parentheses squared is positive 16. And I recopy everything else. Now here, I can move my negative up to the 4 to be in the numerator. I have a choice if I want to move it either to the numerator or the denominator, but just one. Now I do multiplication and division from left to right. So I can do negative 4 divided by negative 2, which gives me positive 2. Next I multiply, and I could either circle just the 4 and the 16 or circle the negative 4 times the 16. In this case, I'm going to circle the 4 times 16. 16 times 4 gives me 64. So I have 2 minus 64. Different signs, so I subtract and take the sign of the higher number, which is negative. So I got negative 62. Try these two, pause the screen, and resume when you're ready. Number 1, 2 times z, which is negative 3, plus x, which is 8, all over 2 times y, which is negative 5. We simplify the numerator, we simplify the denominator, and then we divide, or reduce. So, in our numerator, I'm going to begin with 2 times negative 3, which is negative 6 plus 8, over 2 times negative 5. And now, I can multiply in the denominator, and I get negative 6 plus 8 over negative 10. Negative 6 plus 8 is 2 over negative 10, which when I reduce gives me negative 1/5. Number 2, 3 times z, or negative 3, squared, minus 4 times y, which is negative 5, divided by x, which is 8. There's nothing to do within the parentheses, so I go on to my exponents. Negative 3 is in parentheses. When I square it, I get positive 9. Now that I'm done with exponents, I do multiplication and division from left to right. 3 times 9 is 27. This time, I'll show you what it's like when I circle the negative along with the 4. Negative 4 times negative 5 is positive 20. And I do have to write that plus sign there for the positive. 20 divided by 8 so if I go over here and do 20 divided by 8, it goes in twice, which is 4. I could add a decimal and bring it down to 0. So I get 2.5. 27 plus 2.5 equals, and now when I do 27 plus 2.5, I do have to line up decimal points because I'm adding. 0 plus 5 is 5, keep the decimal where it is, 29, and I get 29.5. Now dividing with fractions is slightly scary looking, but we've been doing this now for a couple of years. If I evaluate x divided by y, and both x and y are fractions, rather than writing it as x, negative 3/4, over y, which is negative 5/2, which gives me this funky fraction within a fraction, I could write it horizontally, because x over y is the same thing as x divided by y. So I can write negative 3/4 divided by negative 5/2. As you know, dividing by a fraction is the same thing as multiplying by its reciprocal. So I take my negative 3/4 and I multiply by the reciprocal of the second fraction. So I flip it upside down and get negative 2/5. Now I check to see if I can cross reduce, and I can. This gives me negative 1 and this gives me 2. And when I multiply across, I get positive 3 over positive 10. 3/10. Number 2. I think of this horizontally as x divided by y. So I have 8 divided by negative 4/5. Well, 8 is like 8 over 1. And when I divide by a fraction, I multiply by the reciprocal. I can cross reduce and get negative 10 over 1, or negative 10. And when I evaluate p over r, I think of it as p divided by r. So 3/2 divided by negative 3/4, or 3/2 times negative 4/3. Cross reduce, this gives me 1, negative 2. The 3's become 1's, so I have negative 2 over 1, or negative 2.